We've talked most of last week about dosage calculations, and we spent the last couple of days talking about IV flow rates and reverse calculations for IVs. So I want to take the first half or so of class today to review those IV calculations because they can be a little tricky. So we'll start off with a forward calculation on a simple IV flow rate. And so what we're looking at here is we have an order for heparin, 5 million units over 4 hours. And we look at our supply, the label on our supply is telling us that that is set up at 1,000 units per milligram, constituted at 25 milligrams in 12 milliliters, and with a drop factor of 16 drops per milliliter. So I want to start off today. I'm going to have you guys in your notes try to calculate for me how many drops per minute that would come out to be. I'll give you about 1 minute and then we will go over that. Okay, let's go ahead and work through this. So we'll start off with the doctor's order here again, as always. 5 million units over the time of 4 hours. Now our dosage is given in minutes, so one of the first things I would do is get rid of those hours. So 1 hour is 60 minutes. So that cancels out the hours, and we now have minutes as our time. And that's what we want, is minutes in the bottom of our fraction. So now we have to get rid of units in the top of our fraction. So we'll put units on bottom here. And we have 100,000 units per milligram. So this would be just 1 milligram on top. And so the units are canceled out. We're now in milligrams per minute. Well, we still want to get away from that yet. The next step would be we could change our milligrams to milliliters using that equivalency. So again, milligrams are on top, so I'm going to put milligrams on bottom here. 25 milligrams and 12 milliliters. So the milligrams cancel out. And then finally, after I get rid of the milliliters, I have my drop factor. So I'll put milliliters on bottom. 16 drops per milliliter says that 1 milliliter is equivalent to 16 drops. So the milliliters cancel out. And now it's a matter of multiplying things out and dividing. Now I am going to get rid of some zeros here to make this a little easier on me. So I have 3 zeros here. I'm going to get rid of 3 more zeros there. I have 1, 2, 3 zeros here I can get rid of. So I get those 2 and that 1. Get rid of 3 more zeros up top. So I have 5 times 1 times 1 times 12 times 16. So 5 times 12 is 60 times 16 is 960. That is drops. On bottom now it's just 4 times 6 times 1 times 25. So 4 times 6 times 25 is 600. That is minutes. Now let's divide that out. 960 divided by 600 gives us 1.6 drops per minute. So that 5 million units of heparin sounded like a very large dose, but it was spread out over 4 hours, came out to not quite 2 drops per minute when we set up our IV. So then we looked at reverse calculations. And so reverse calculations meant we weren't necessarily given all of the information to set up the infuser. We had to take the information we were given and work backwards to it. So one of those would be to look at the order or the bag. So either it's the full doctor's order or it's just the size of the bag. In this case, let's just say it's the size of the bag is 1,500 milligrams of medication in that bag. And we look at the setup and we see that we're going to have to switch this bag out at some point. So we want to find the time to complete infusion. In other words, when will the bag be empty so that we have to come back and change it? Then we look at our settings. And our settings on the infuser, it is set at 30 drops per minute. And we look at the label on the bag. And that label, of course, tells us that it's the 1,500 milligram bag. But then it also tells us that we are constituted at 15 milligrams in 4 milliliters with a drop factor. Let's see, 12 drops per milliliter. And so we want to find the time it's going to require for that bag to be emptied so that we can change it. We will start here with, we have a number of options. I showed you last Friday that we can start any one of 3 spaces and we're going to get the same result. So here, I'm just going to start out with the size of the bag, 1,500 milligrams. I'm going to put that over 1, and we're going to see where that takes us. Remember, the worst that can happen is we end up with the units we want on the bottom of the fraction. We have to use a reciprocal. So here, oops, get back here. We want to get rid of the milligrams, so we're going to put milligrams on bottom. And let's see here. We have 15 milligrams and 4 milliliters. That gets rid of the milligrams. We're now in milliliters. We don't want milliliters either, so we're going to get rid of milliliters. We have 12 drops per milliliter, so that's 12 drops in 1 milliliter. So we've got rid of the milliliters. Well, we don't want drops either. We want a time, so let's go to the next step. Get rid of drops. That's our setting on the infuser is 30 drops per minute. So that's 30 drops in 1 minute. So right now, this will give us minutes if we go ahead and complete this calculation. So on top, it is 1,500 times 4 times 12, giving us 72,000 minutes. On bottom, 1 times 15 times 30 is 450, so we just divide that by 450, giving us 160 minutes. We could leave it at that, or we could do the conversion and turn minutes into hours. We know that 1 hour, 60 minutes. The minutes will cancel out. This becomes 160 over 60 hours, and we can reduce that. Now, the way I would reduce this is I would actually use division and remainder. 160 divided by 60. 60 goes into 160 twice. 2 times 60 is 120, so that's 40 left over. So this is saying it's 2 hours and an additional 40 60ths, or 40 minutes beyond that. So 2 hours and 40 minutes would be our infusion time there. So if we look at another example, let's say that we have, again, we find that the setting on the infuser is set at 32 drops per minute. We look at the label on the bag, and it tells us it's a 2,400 milligram bag that is constituted 12 milligrams in 5 milliliters with a drop factor of 8 drops per milliliter. So again, I'm going to give you guys about a minute. I want you to find how many hours and minutes before that bag would need to be changed. We'll go over this in about a minute. So if we start off with our amount of our bag, 2,400 milligrams. We'll just put that over 1. The only thing we have that has milligrams in it is right there. So I'm going to put 12 milligrams. 5 milliliters would go with it on top. So the milligrams have canceled out. Next, we need to get rid of the milliliters. We have 8 drops per milliliter. So milliliters on bottom, 1 milliliter is 8 drops. And finally, we would need to get rid of the drops. That brings us to our setting here of 32 drops. So our drops have to go on bottom to cancel out the drops in 1 minute. So our only time left is minutes. So let's go ahead and find our minutes. So we have 2,400 times 5 times 8 times 1 minute is 96,000 minutes. Over on bottom there, we have 12 times 1 times 32 is 384. So we just divide that out. 96,000 divided by 384 gives us 250 minutes. So once again, we'll do that conversion. Rather than setting it up, I'm just going to do 250 divided by 60. We see that 260 goes into 250 4 times, so that's going to be 4 hours. 4 times 60 is 240. We subtract, there's 10 left over, so that's 10 minutes. So this would take 4 hours and 10 minutes to infuse that medication into the patient. So that would be the point. 4 hours and 10 minutes in would be when we would want to change that IV bag. So the next one we want to look at is a little bit different. Let's say we have a setting of operating at 40 drops per minute. And we see that the order on the chart is for 2,000 milligrams over 5 hours. Easier for you. And our label on the supply is telling us that this is, check the right one here, 5 milligrams in 2 milliliters with a drop factor oops, sorry, we're going to find the drop factor. So that's our missing piece of information here is the drop factor. Let's go ahead and see what we come up with here. So I would typically start with the doctor's orders and see where it takes us. So we'll start with 2,000 milligrams over 5 hours. Now we don't have anything else here that's in hours, so I'm going to start out by changing my hours into minutes. So 1 hour is 60 minutes. Hours have canceled out. Now that I have that, I can continue to either get rid of minutes or the milligrams, either one. I'm going to go ahead, since we've got minutes on there, let's get rid of minutes. We have the setting there, 40 drops per minute. So that's saying 1 minute is equivalent to 40 drops of flow. That's canceled out the minutes. We now have drops. Remember, drop factor is in drops per milliliter. So drops is one of the units we have. Now we're going to end up with drops on the bottom here, which means the milliliters are going to have to be on top. And then we'll have to do a reciprocal later. So on bottom, we have milligrams. Cancel out milligrams here. We have 5 milligrams in 2 milliliters. So the milligrams have canceled out. We now have milliliters over drops. We want drops over milliliters, so this is fine. We're going to get the reciprocal of what we want. So before we reduce, once we calculate this out, before we reduce it, we are going to do the reciprocal. So on top, we have 2,000 times 1 times 1 times 2 gives us 4,000 milliliters. On bottom, we have 5 times 60 times 40 drops times 5 gives us 60,000 drops. Now, like I said, before we reduce this, we see that we have milliliters on top and drops on bottom. And we want the opposite. We want the drops on top and milliliters on bottom. So we're going to go ahead and flip that and take that reciprocal. So we'll put the 60,000 drops on top and the 4,000 milliliters on bottom. So now we'll go ahead and divide out by 4,000. That's going to give us 15 drops per milliliter. So that is our drop factor for that medication. It's 15 drops per milliliter. Let's have you guys try one there. We're going to give this as a setting at I was setting at 40. Okay. So let's let this one set at 50 drops per minute. And the order is for 15,000 milligrams over 5 hours. Our label is telling us that we are constituted at 20 milligrams in 1 milliliter. So again, we're going to find the drop factor. So I'm going to give you again about a minute in your notes to find that, and then we'll go over it. Let's take a look, see how you did here. So again, I would start out with 15,000 milligrams over 5 hours. Now, once again, there's nothing else here labeled in hours, so I'm going to get rid of the hours first. 1 hour is 60 minutes, so the hours have canceled out. We'll continue to get rid of the minutes. I'll put minutes on top, and I have 50 drops is equivalent to 1 minute. So the minutes cancel out. Well, we want drops. It's on bottom, and we're going to want it on top. So again, we'll do a reciprocal in a little bit. Our next step, we want to get rid of the milligrams. So milligrams are on top. We're going to put it on bottom. We have, oops, we've already used that one. We want this one here, 20 milligrams in 1 milliliter. So the milligrams will cancel. So on top here, we have 15,000 times 1 times 1 times 1 milliliter. That's just 15,000 milliliters. On bottom, we have 5 times 60 times 50 drops times 20 equals 300,000 drops. For some reason I crossed off the 20 there, I should have crossed off the milligram. So now before we divide that out, we're going to do the reciprocal. So I'll put the 300,000 drops on top and the 15,000 milliliters on bottom. And so we're going to have drops per milliliter. And when we divide out the 15,000, 300,000 divided by 15,000 is 20. So 20 drops per milliliter. So next we want to take a peek at how much will be infused. So this is an example we have not done. So if we have an order that says it's going to be over 3 hours. Doesn't say how much, just it's going to last. This IV is going to hang for 3 hours. We look at our setting. And the setting is set for 45 drops per minute. And our label on our bag tells us that it is constituted in 25 milligrams in 9 milliliters with a drop factor of 15 drops per milliliter. And we want to find milligrams of medication that's going to be administered over this period of time. This is an important calculation coming up over the next 2 weeks. We're going to talk about safe dosages and verifying that a dosage is safe. This would be an example of that type of calculation where we need to make that verification that this dosage is safe. So now here we can start with really any of the numbers we have here. I'm going to start with the order of being over 3 hours. Actually, you know what? Let's do this. Let's start. We know we're going to want our answer in milligrams. Let's start with milligrams. So we'll do the 25 milligrams in 9 milliliters. So that's 25 milligrams is equivalent to 9 milliliters. So we know we want to keep the milligrams. We just want to get rid of all of the other units. So I'm going to get rid of milliliters. I'm going to put it on top. Right here I have 15 drops is equivalent to 1 milliliter. So I get rid of the milliliters. Next, we need to get rid of the drops. We'll have the setting here is saying 45 drops in 1 minute. So that cancels out the drops. Now my time is set for 3 hours, so I need to change my minutes into hours. I'll put 60 minutes on top here to cancel out the minutes into 1 hour. Now I don't want the hours in there, right? That would give me 25 milligrams per hour. I want to know just the volume. So this is where this time comes in of 3 hours. So we'll put 3 hours on top here over 1. Come on. So that'll cancel out the hours, and the only units I will have left are those milligrams. So let's go ahead and multiply this out. On top, we have 25 milligrams times 1 times 45 times 60 times 3, which gives us 202,500 milligrams. Over, on bottom, we've just got 9 times 15 times 1 times 1 times 1, which is 135. So we take that 202,500 divided by 135, and we get 1,500 milligrams. So in that 3 hours, we would infuse 1,500 milligrams of medication into that patient. So I'm going to have you guys try one here. So our order is to administer the medication over 2 hours. And the setting on the infuser is at 45 drops per minute again. And we look at our label on our bag. And our label is telling us that we are constituted at 18 milligrams in 5 milliliters with a drop factor 18 drops per milliliter. So once again, I want you to find the milligrams for me. I'll give you about a minute, then we'll go over that one. So here again, you can start in a number of different spots. Could have started with the 2 hours, could have started with milligrams. Again, we know we want milligrams, so I'm going to start with something that already has milligrams in it. 18 milligrams is equivalent to 5 milliliters. Now we want to keep the milligrams, we want to get rid of the milliliters. So I'll put milliliters on top. Look for something, we have a drop factor has milliliters in it. That is saying 1 milliliter is equivalent to 18 drops. So the milliliters have canceled out. We now have drops. Well, I want to get rid of those drops. We have the 45 drops. Drops will go on top so that they'll cancel out per minute. So the drops have canceled out. We're now in minutes. Well, we don't want the time in here either, but our only other time we have is in hours. So let's go ahead and get rid of minutes. Putting it on top, so 60 minutes is 1 hour. That'll cancel out the minutes. And then we get rid of the hours by using our 2 hours that are specified. The hours will cancel out. So we go ahead and multiply on top here. We have 18 times 45 times 60 times 2, giving us 97,200. That is milligrams. On bottom, we have 5 times 18, which is just 90. Take that 97,200 divided by 90, and we get 1,080 milligrams. So, 1,080 milligrams is the amount of medication that would be infused over that amount of time. So, this type of calculation, again, is very important to check safe dosages to make sure we're not giving too much medication to the patient. Anytime you come on to a shift, if there's an IV that's already running from a previous shift, you should double check that calculation to make sure you know, does this bag need to run empty, or do I have to remove this bag at a certain point to stop the medication at a limit? So what we have done so far has been pure dosages. And what that means is these dosages do not depend on any characteristic of the patient. And so what that means is the dosages are just there. There's no figuring in weight or anything else. And the factors that we could figure in, it could be weight, could be age. Is it a pediatric dose? Is it an adult dose? Or another one that we'll actually do before we're done here is body surface area. And so all of these are characteristics that can be used to calculate dosages. Let's take a look at weight. So if I'm looking at a recommendation for weight, we might look up in some sort of a reference or whatever, that for a particular medication, the recommended dose is 5 milligrams, oops, not 5, sorry, 6 milligrams, 8 milligrams per kilogram. So what this is doing is this is giving us a minimum and a maximum amount. So the minimum dose would be based off of that 8 milligrams per kilogram. Or sorry, 8 milligrams. 6 milligrams per kilogram. Can't talk today. And the maximum dose would be based off of the 8 milligrams per kilogram. So let's say that we know, if we're given that the maximum dose is 640 milliliters. Obviously, there's a process similar to what we have done for our other dosage calculations to get to that 640 milliliters. If we want to know what the minimum dose is, without having to go through that whole calculation again, there's a process called a titration. And what a titration does is it allows us to change one of the parameters of the calculation. That parameter could be the concentration of the medication, could be the weight of the patient. Here, it's whether it's the minimum dose or maximum dose. So the way we do a titration is we take the known dose, in this case, 640 milliliters, and then we multiply it by a ratio or a fraction. This ratio is going to use what we have on bottom and what we want on top. So what we have used here in this 6 milligram to 8 milligram per kilogram recommended range, we have used the 8 milligrams per kilogram. So that goes on bottom. We want the 6 milligrams per kilogram. That's going to go on top. Now, it's also very important here that these units are the same for both of these numbers in this ratio, so that they cancel out and they don't affect the calculation. So now we calculate this by doing 640 times the top number of 6 and divided by the bottom number of 8, giving us 480. The units on this will be the same as the units we started with because these units canceled out. So that's 480 milliliters would be the minimum dose. So that means our acceptable range here would be from 480 milliliters to 640 milliliters. Like I said, this type of titration can be used for any sort of calculation. Let's say that we know, I'll give you an example here, where that we know that the doctor has prescribed 360 milliliters for a 90-pound patient. And we want to know how much should we be using for a 75-pound patient. So we know that the 360 milliliters is our dosage. And that was being used for a 90-pound patient. So that goes, 90 pounds goes on the bottom in our ratio. We want to change it to 75 pounds. Now, even though this dosage was probably based on an amount per kilogram, it does not matter that our weight here is given in pounds. Because, as we said, these units, as long as these units are the same, they cancel out, and it's still an accurate ratio of the size of the patient. So here we would do 360 milliliters times 75 divided by 90 is going to be 300 milliliters. So the new patient, the 75-pound patient, would get 300 milliliters. So obviously our next step, we're going to talk about dosages based on weight. And so when we look at dosages based on weight, what we're going off of is a recommendation. So the doctor's order is to give the recommended dose of this medication. And so we look at the recommendation. I'm just going to do REC for recommendation. And it says to give 250 mcg. Now remember, that is micrograms. That's the medical way of writing micro instead of using UG for micrograms. So 250 micrograms, 300 micrograms per kilogram. And we have a patient that weighs 88 pounds. And our label on our supply says that it is constituted at 25 milligrams in 16 milliliters. So the first thing we need to do here is figure out kilograms, because this is based per kilogram. So this is stretching back into unit 2. We take our 88 pounds times, pounds are going to go on bottom, kilograms on top. We know that 1 kilogram is 2.2 pounds. So the pounds will cancel out. This is just going to be 88 divided by 2.2, giving us 40 kilograms. This is a calculation we're going to do often enough that we're not going to set up this dimensional analysis every time. We just know to get from kilograms to pounds, or from pounds to kilograms, I should say, we're going to divide by 2.2. Now we start with the 40 kilograms. We're going to use the maximum dose. If we're double checking a doctor's calculation, the first thing we want to do is make sure they didn't get too much. So a kilogram is going to go on bottom. This will be 300 micrograms on top. The kilograms have canceled out. Well, we want to get, this is a liquid medication, obviously, so we're going to administer it in milliliters of volume. We have milligrams to milliliters, so we have to get rid of the micrograms first. So micrograms to milligrams, 1 milligram is 1,000 micrograms, canceling out the micrograms. Now we can take that final step to get rid of milligrams and 25 milligrams in 16 milliliters. So we go ahead and calculate this out. 40 times 300 times 16 gives us 192,000 milliliters over 1 times 1,000 times 25 is 25,000. So we divide that out, giving us 7.68 milliliters is the maximum dose. To get the minimum dose, we do that titration. Where we used 300 micrograms per kilogram. And we want to switch it to the minimum of 250 micrograms per kilogram. So we do times 250 divided by 300. Gives us 6.4 is the minimum. So we'd have a range there of 6.4 to 7.68 milliliters of fluid of that medication. We're out of time, so I'll give you the homework. First page is page 172 through 173, 1 through 9, dealing with IV calculations. And then page 178 through 179, 1 through 21, dealing with some of the reverse calculations. So the rest of this week, we're going to look at dosages based on weight and body surface area. We won't have class on Friday, obviously, because of the holiday. It looks like our Unit 3 test, if everything stays as scheduled, will be next week, Friday. So that will be, what is that, the 14th. So be prepared for Unit 3 tests coming up on the 14th. I'll get those out early next week. With that, you guys have a great day, and we'll see you all on Wednesday.